Hello everyone, myself Forum Mokwana, Assistant Professor of EC Department at LG Institute of Media Technology. Welcome to the session of Digital System Design. So, from chapter number 3, that is a sequential or circuit design, we have seen the different types of flip-flop, counter, types of counter, and we have started what we mean by shift resistor. Okay? So, in today's session, we are going to start the different types of shift resistor, its application and its characteristics. Okay. So first of all, the definition of shift resistor, as we have discussed, that it is used for data storage and the movement of data. Okay. So it is a digital circuit with having two basic functions. So the shift resistor provides a data movement function, first task, and second task is the shift resistor shifts its output once every clock cycle. Alright? So it is a group of flip-flop which is set up in the linear fashion with their inputs and the outputs connected together in such a way that my data is going to be shifted from one device to other device. One circuit is active only. Alright? So the application of the shift resistor, first is the converting between the serial data into parallel and vice versa, and it is used for temporary storage in the microprocessor, also used for the arithmetic and logical operation, used for communication, say what? In some counter applications like ring counter, Johnson counter, the linear feedback shift register, and time delay devices. Okay, this is the example how it looks like. The shift register, it consists of the 4 flip-flops. You can see that we are going to use a D flip-flop. The 4 flip-flops are there; they are going to be synchronized at the same time, and the clock pulse is given to all flip-flops. Alright. It has only a single output when we are going to shift the data serially, and it has a multiple outputs based on the number of flip-flop when we are going to transfer the data parallelly. Alright. So what are the characteristics of shift resistor? The first is it can shift the data whether in left, right, rotate and bidirectional. Types are like serial input, serial output, serial input, parallel output, parallel input, parallel output, and parallel input, serial output. Okay, this is the block diagram how it looks like. See, this is the n bit shift resistor in which serial input is there and serial output is there. Single input, single output. Now, for serial input, parallel output, it consists of single input and the multiple parallel outputs are there. Okay. See. Then parallel input, parallel output. Parallel input, parallel output. Okay. And parallel input, serial output. Alright. See, this is the preset control used to activate shift register. This is the shift pulse. We need to shift whether left shift is there or right shift is there. This is the clear control to clear the shift resistor. Okay, so these are the characteristics of shift resistor. Now, how the data movement will be done? See. The bits in the shift resistor can move in any of the following manners. It is like serial input shift resistor. It can be shift in the right or shift left. Alright. Then serial input and shift left and serial output. Okay. Second, serial input, parallel output, parallel input, parallel output. And over here, for parallel input and parallel output, there is no shifting operation. It is used for only a shifting left or shifting right is there. Alright. Now, If you want to rotate the data, whether the right rotation is there, it is like this, and the left rotation is there. Alright, and based on the parallel input, we are going to do the serial output for the parallel in serial output. This is how data will move, whether it is rotation, whether it is shifting, whether it is a transmission of data in serially or parallelly. Okay, this is the way how data movement will be done. Now, we will see the block diagram individually for the data movement. This is the block diagram for the shift register with the various input-output options. Alright, first consider that my first case, parallel input, serial output. See, for all the movement of my data, there is three. The preset control is there and the clear control is there for all the cases. Okay, and the shift pulse will be there whenever we are going to shift the data. Right? Parallel input, serial output. So shifting is there whether we are going to shift the data in the left or the right direction. Right? Second, serial input and the serial output. This is a generalized diagram that we have seen. Right? Now, serial input, parallel output. Over here we don't need to shift the data over here. That's why shift pulse is not there. Only the clear control is there. But if we want to do a shifting operation, whether a data will be shifting right or left, so we can apply the shift pulse. Right? Now for the serial in and serial out, shifting is there whether data is moved in the left direction or the right direction. Clear control is there and the preset control is there. So this is the example of how the data movement will be done. See, this is the diagram which you can see that stage A, B, C, D represents the 4 flip-flop, right? Serial in, serial out. First, SISO. Clock pulse is at the edge of the clock pulse, my data will be moved. For parallel in, parallel out. At the edge of the clock pulse, data will be out. Parallel in, serial out. And this is the example of serial in, parallel out. This one. Okay. This is the IC that we are going to use for this shift operation. Now, let us first consider the serial in, parallel out. The data bit will comes out in one at a time and leave one at a time. Okay? At a time, one input is there, will come in and one output will come out. Okay? So movement can be left or right. So it is usually only in the single direction, either whether we are going to move in the right direction or in the left direction. Right? The asynchronous preset and the clear inputs are used to preset and to set or to reset the counter values, or we can say the register value. Right? So there are 4 flip-flops are there. At the edge of the clock pulse, serial inputs are taken and we will get the serial output. Alright? So this is the n bit shift register logical diagram with the help of SR flip-flop. Okay? Here it is SR flip-flop. So we have implemented with the help of D flip-flop. How to convert the D flip-flop into SR flip-flop? Simply place the NOT gate. Alright? Remaining circuit will be as it is. If you want to perform the shifting operation, whether shift left or shift right. So for shift left, it will be like one shift left. If its value is 0, then perform the shift right operation. Right? So this is logical circuit diagram. This will act as a pre-flip-flop, and the inputs values are going to the output of the each flip-flop with the help of clock pulse. Right? Now, the shift register is the only one that we use for flip-flop. So the output of one flip-flop is connected to the input of its next flip-flop, next adjacent flip-flop. Okay? Each clock pulse will be applied to individual flip-flop in such a manner that my whole shift register is synchronous. Right? With the help of clock pulse, my value of content of the flip-flop is going to be shifted. Alright? So the serial input determines what goes into the leftmost side during the shift time. Alright? And the serial output is taken from the last flip-flop, which is the output of the rightmost side of the flip-flop. This is the way how we can draw its logical diagram for serial in, serial out. Right? This is a simple way of looking at the serial shifting. See, over here input data in. Input is there, 1. Okay? At the edge of the clock pulse, it will be shifted like this. At the edge of the clock pulse, it will be shifted like over here. Again, at the edge of the clock pulse, it will be shifted over here. This is shift right operation. Okay? As we need to shift the data when it is a 1, 0, 1, 1. First clock pulse, 1 is inserted. Second clock pulse, this 1 is inserted. Third clock pulse, 0 is inserted. For the fourth clock pulse, it is 1, 0, 1. Okay, and for the output, again, clock pulse is there. So 1 will be out. Right?